Hello, judges. Today we want to talk to you about our proposed solution for the American Electric Power Safety Observation Challenge. We iterated through many different ideas initially. We looked into many different open source LLMs such as Ollama, OpenAI, and Burr. There were many different positives and negatives from each LLM. Ollama was easy to use, but wasn't productive for the text data learning that we needed to use for this solution. Our OpenAI had some difficulty with using a free secret API key. Burr was simple to use since they already encompassed the sentiment analysis into the model, which is what we wanted to use when looking into the level of severity for the comments, which was all used by text data.
We decided to utilize two libraries to complete this project, Panda and Transformers. These helped us with establishing our LLM model, BERT. Using pandas allowed us to iterate through each line of the given CSV file. The Transformers import is essential to initialize the LLM that we are using.
We used the pipeline command to choose which model we wanted to use based off the LLM and based off a model that would help us with the classification. The BART large MNLI is known to be effective for many cases, and we wanted to work with a pre-trained model compared to our own model, just due to time and due to the unnecessary redundancy to the abundant number of models. And there's many abundant number of models that could fit our need. Specifically, with the zero-shot classification, it's essential to a project since it can classify the proper objectives without having to be trained, which is something that we realized was very effective and efficient compared to the implementation that we wanted to use. So you can see that
we chose to set up our hazard categories as highly concerning and no concern, as the prompt asked us to focus on the high severity safety concerns. This allowed us to clearly indicate which comments deserve attention and which did not. This line reads in the CSV file and then assigns its value to a variable so it can easily be accessed. The second line converts comments to a list. This function takes in the comments from before and the categories we want it to classify them into. It iterates through every comment and calls the classifier we initialized earlier to provide us with its best fit category and its confidence score. This line of code calls the function classified comments and stores its output into a variable. This line makes a new data frame and prints it out to a new sheet. The output is formatted in a new CSV file that has comments, the category, and its confidence level. Confidence level is important so people can see which comments are more important amongst the ones that are already classified as concerning. This is our output. As you can see, it shows a confidence level and the level of severity, either high concern or low concern. By using the BERT LLM, we were able to visualize what comments were of high severity effectively with our model that creates a confidence level for each instance. By implementing the LLM, we can implement this to any dataset that discusses safety comments for the AEP.